Hello friends, welcome to Engineering Funda family. In this video, I'll explain you gain of antenna with great clarity. Before I start with explanation, let me show you how many things that I'm going to cover in this video. See, first of all, I'll be explaining you basics of gain of antenna. After that, I'll be explaining you relation in between gain and directivity of antenna. After that, I'll be solving two interesting problems based on gain of antenna. So let us initiate this video with first agenda, that is basics of gain of antenna. So first of all, you need to understand how we measure gain of antenna. See, gain of antenna is measured as per radiation intensity of given antenna with respect to radiation intensity of reference antenna. So if you want to measure gain of antenna, then gain of antenna can be measured by the radiation intensity of the antenna under test with respect to radiation intensity of reference antenna. So basic equation of gain of antenna is radiation intensity of antenna under test divided by radiation intensity of reference antenna. That is how one can calculate gain of antenna. And usually you will be observing this reference antenna that will be isotropic source. So as if reference antenna is isotropic source, in that case we can identify radiation intensity of reference antenna. Let me explain you how. Here, as if I say we have isotropic source, then with isotropic source you will be observing equal radiation happens in all the direction. So if I say here we have isotropic source, then equal radiation that will happen in all the direction by isotropic source. So as if isotropic source radiates equally in all the direction, you will be observing radiation pattern will be sphere with isotropic source, right? So for isotropic source, if you want to measure radiation intensity, then radiation intensity can be measured as per U reference, that is equals to amount of power given to this isotropic source divided by solid angle, right? So here we have input power, that is P in, divided by solid angle, that is rho. And for complete sphere, what is solid angle? It is 4 pi. So here with isotropic source, this solid angle is 4 pi, right? So here we have radiation intensity of reference antenna, that is P in divided by 4 pi. So what we can do is we can substitute this reference antenna's radiation intensity in basic equation of gain. So now we will be having modified equation of gain, that will be radiation intensity of antenna under test divided by radiation intensity of reference antenna, that is P in divided by 4 pi, right? So if you substitute this reference antenna's radiation intensity, that is P in by 4 pi, then modified equation of gain will be 4 pi into radiation intensity of antenna under test divided by P in, right? That is how one can derive gain equation. Now based on this gain equation, we will be establishing relation in between gain and directivity of antenna. So first of all, you need to know what is radiation efficiency of antenna. That even I have explained in my earlier videos. Still, let me explain it again. See, here we have antenna. With this antenna, let us say we have input power, that is P in, and this antenna is radiating EM waves. Let us say radiated power is P rad. So based on radiated power and input power to this antenna, one can calculate radiation efficiency, that is radiated power divided by input power, right? So radiation efficiency, that is radiated power divided by input power. See, in this video I have derived equation of gain, that is 4 pi U divided by P in, right? So gain is 4 pi into radiation intensity of antenna divided by P in. And in my last video, I have explained directivity. Directivity of antenna is 4 pi U divided by radiated power, right? That is what I have explained in my last video. Directivity is 4 pi into radiation intensity divided by radiated power of antenna. So based on these two equations, one can calculate relation. See, here what we will be doing is we will be dividing equation 1 by 2. So G divided by D, that is equals to 4 pi U divided by P in, that divided by 4 pi U divided by P rad. Here this 4 pi U, that is getting cancelled. So we will be having P radiated divided by P in, right? And P radiated divided by P in is how much? Radiation efficiency, right? So basic relation in between gain and directivity is gain is equals to radiation efficiency into directivity. This is very essential relation in between gain and directivity, right? Gain is equals to radiation efficiency into directivity. Now let us solve two interesting problems. In first problem, we are given with the radiation resistance of antenna, that is 72 ohm. Let me note down all the datas. So here we have been given with radiation resistance, that is 72 ohm. Here loss resistance is also given, that is 8 ohm. So loss resistance, that is 8 ohm. What is the directivity of antenna if antenna power gain is 16? So here gain is given, that is 16. So based on that, we need to identify directivity of antenna. See, here we have been given with radiation resistance and loss resistance. Based on that, we can identify radiation efficiency. That even I have explained in my earlier videos. See, radiation efficiency, that is radiation resistance divided by radiation resistance plus loss resistance. Radiation resistance is 72 and loss resistance, that is 8. So 72 divided by 72 plus 8, 80. So 72 divided by 80, that is 9 by 10. So you can say that is 0.9, right? Now we have radiation efficiency, right? So based on that, one can have calculation of directivity. See, gain is equals to radiation efficiency into directivity. So directivity is gain divided by radiation efficiency. Here gain is how much? 16 divided by radiation efficiency, that is 0.9. So directivity will be 17.77, right? This is there in terms of value. And if you wanted to have this directivity in form of dB, then you'll have to do calculation as per 10 log of 17.77, and that will be there in terms of dB. It will be around 12.498 dB, right? That is how one can identify directivity based on radiation efficiency and gain. Now in second problem, what is given? You see, an antenna has loss resistance of 10 ohm. So here we have data that is given where loss resistance, that is 10 ohm, power gain is given, that is 20. So here we have been given with gain, that is 20, directivity is 22. So directivity, that is 22. We need to identify radiation resistance of antenna, right? So radiation resistance, that one can calculate based on radiation efficiency, and radiation efficiency can be calculated based on gain and directivity, right? So if you want to calculate radiation efficiency, then gain is equals to radiation efficiency into directivity. Based on that, radiation efficiency is gain divided by directivity. Gain is 20 and directivity is 22. So you can say that is 10 divided by 11. And in terms of value, you can say it is 0.909, right? Now we will be identifying radiation resistance based on radiation efficiency. See, radiation efficiency, that is radiation resistance divided by radiation resistance plus loss resistance. So here this radiation efficiency that is given, that is 10 by 11, that is 10 by 11. Radiation resistance that we want to calculate, and loss resistance that is given, that is 10 ohm. Just do cross multiplication here. So 10 into RR means 10 RR plus 10 into 10, that is 100, that is equals to 11 RR, right? And see, if you take this 10 RR on other side, so 10 RR that is getting subtracted from 11 RR, so you'll be having RR only. So you can say radiation resistance RR, that is 100 ohm over here, right? So that is how one can calculate radiation resistance based on radiation efficiency, and radiation efficiency can be calculated based on gain and directivity of antenna. I hope now basic fundamentals are clear with you. Still, if anything that I'd like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.